Good afternoon, my name is David Martin and I'm talking today about ASX Trading versus machine learning, MLOps by accident. First though, I'd like to say thanks to the sponsors for allowing us to have this conference. It's a great opportunity. So the other thing I'd like to open with is this is not financial advice. Please don't rush out, get a CommSec account and blow next month's rent or your mortgage. I'll get in trouble for that. So why am I here? For me, my machine learning journey started with the New York City taxi fare prediction project. So I found that on the Microsoft website back in late 2019. And what it let me do was it let me experience machine learning with C# in a very easy and comfortable way. And a taxi fare is an easy thing to predict. It's the name of the taxi company, the distance traveled, time of day, so on and so forth. And what I could see from that, without teaching the code anything at all, it could read this data file and make predictions from it. So straight away I could see, I was interested by the subject, but also that code could learn something. And so I was quite fascinated by that. The thing was, in my experience with that project, I was hard-coded. So every time I wanted to add a new feature, remove a feature, make an alteration, I had to change the code and recompile it. And I wondered if there was a way to dynamically change it. So I could upload any data set with different features and data points and see if it could just test it and use it and predict from it. So what I ended up doing was I ended up building a tool for myself, and I've called it Data Shark. And what it let me do was create data files, upload them, and it didn't know in advance what they were. It could go through and test all the permutations of data and machine learning parameters and find the most optimized solution for me. So it could test hundreds and thousands of models for hours, completely automatically. So once I'd achieved that and I was quite satisfied with it, I tested it with healthcare data. I'm from the healthcare sector. I've been in public health now for about 17 odd years. I tested on a variety of models, cancer models, breast cancer, that sort of thing. And I found that I was happy with it, but it wasn't really as successful as I hoped. So I decided to pivot to fintech, which is a passion of mine. I've studied in finance, financial planning. So I thought I'd combine IT with finance and go into ASX trading and see if I could use machine learning and try and work out the features that I needed to be able to predict a trade in advance, which brings me to today. So my agenda for this talk is, the first part of it is my trading strategy. What trading strategy was I going to use or model in machine learning? The second component I want to cover today is machine learning in a minute. I just want to cover some quick calculations and just so you have an appreciation of how it all fits together. And the key part of the talk is MLOps, or machine learning operations. And that's how, having these hundreds of thousands of models, how I deploy them, destroy them, how they're used at scale and automatically, because after all, I'm a one-man band. And at the end, if there's time, a quick anecdote about my experience so far. So let's start ASX. So I have my own self-managed super fund, and part of my need is to automate that trading. Look for opportunities and trade them automatically if possible, or at the very least, bring them to my attention. Just like everyone else, busy person with things to do. The first thing to consider with share trading is shares are not traded. In fact, it's information and sentiment. It's how you feel, how people feel about a company. You may feel more comfortable buying, say, CBA shares versus a small startup you may not have heard of before or seen on Twitter somewhere. So it's important to remember that information and sentiment is what drives trading behavior, the buying and selling of shares. And because sentiment or emotion drives trading for a lot of people, then volatility, which is emotion-based, equals opportunity. So what that meant was I had to find an event, a repeatable, reliable event I could use and try and predict when that event would be successful in a trade. So in my particular case, or the strategy I formed was around ASX announcements. ASX announcements are documents that a company is obliged to notify the market of certain events, good news and bad news. And so my strategy, the strategy that I developed or devised was to predict when an ASX announcement from a company would move the share price up by a certain amount. So let's say 10, 15%, or let's say 15%. And then that way we can turn that into a binary machine learning model. Did it move over 15% or did it not? And so that way we can attack the trading strategy by using binary classification and machine learning. Which brings me to the next part, data. So data, as I said there, maketh the model. So the data that I've considered when supporting these decisions, or these machine learning models, is announcement metadata, the time of day, the day of the week, the month of the year, so on and so forth, season if you wanted to. These are all things I've factored in and experimented with before. The title of the document, the company it came from, are all valid choices as features. The other thing I experimented with was sentiment. So there's microservices available from IBM, Azure, Google, that you can do sentiment scoring. And I did that on the ASX announcement titles and used that as a feature as well in my modeling. Another thing to consider, I talked about sentiment before, so Twitter. Twitter's a great place for day traders. News articles, regularly published, a few hundred a day during the trading week. The volume of those announcements, the sentiment of those statements themselves, they're good or bad, and capturing those can help determine the volatility of the movement of a stock. Another good example you've probably seen on the TV is economic indicators. Inflation data you've probably heard about, jobs numbers you've heard about, RBA interest decision, which affects a lot of us with mortgages. Those are all good features and factors that I've considered before in my models. The other thing to consider is trading data derivatives. So moving averages are very common. You'll see them if anyone has a trading account, 5-day moving average, 20-day moving average, 50, 100, so on and so forth. So those things I've considered in my modeling. Also short positions. If you're familiar with the movie Big Short or any of those things, that also drives sentiment. You can see what other people believe if the company's going to go up or down. Next thing I'd like to cover is machine learning in a minute. The first particular calculation is confusion matrix. Now, confusion matrix, as I've written there, is a performance measurement for machine learning classification problems, where the output can be one or two classes. In my case, it's a binary classification problem, so it's very simple, true, false. Now, as you can see from the sample confusion matrix I've got there, the predicted positive is where the machine learning model has predicted that it's going to happen. Now, on the left-hand side, you can see actual positive. Now, actual positive is where, in fact, the machine said yes, and it did happen. The next one below it, the actual negative, is where the machine said yes, but it didn't happen. Moving on from there is precision. Now, specifically with precision, it's important that left-handed column is all the trades we would make, because we don't know in advance whether or not the trade is going to be successful or unsuccessful, and that is the price moves more than 15% and achieves our objective. So in order to measure a model's accuracy while it's being trained and tested, we use a calculation called precision, and you can see I put a sample there using the numbers from the previous confusion matrix. So true positive on the top and the true positive and false positive on the bottom. So as you can see from the score there, 0.28, approximately 28%. So the question asked, is it a good model to trade with? And the answer is no. What it's saying there is 28% of your trades would be successful, which means approximately 70% wouldn't be, and there's a good chance you're losing money. Now, the thing that's important to point out here is that at a 15% target, the share price could have gone up 5 or 10%, but not our goal of 15%. So it's still considered a fail or not a good trade. So moving on from there, MLOps, the necessary accident. The situation I had was the tool I'd built was building thousands, hundreds of thousands of models. How could I determine the good ones to send out and deploy to production and test, and then equally dispose of them? And the need was to automate all of that. I'm a one-man band and there's hundreds of thousands of models. I couldn't develop APIs for each model as they were deployed. I couldn't manually deploy or destroy them, that sort of thing. I had to make it completely automated, so any future model that was deployed, so met my criteria, was automatically deployed. So I invented yet another tool. This one I decided to call Scarborough Fare as a marketplace. Now, as any marketplace, it has market rules. I decided that one of the minimum criteria was a confidence score. Now, every machine learning prediction has a confidence. How confident is the model that the prediction is accurate? I started off with a 60% accuracy rate. So if the model was 60% sure the prediction was going to be successful or positive, then I would score the precision that way and deploy that model to production. And that's the bit I named Market Maker. So that's the continuous delivery. So those models, if they met my criteria, were deployed to production. The next place I've named CD+, is in the DevOps sort of paradigm. So CD+ is the continuous deployment. continuous deployment meant the model was immediately exposed to production data in real time without me lifting a finger. So the idea of building an API that could know the features the model needed in advance and simply provide them to the model, and in return the model gave back a prediction, hence the idea of a marketplace where one thing is traded for another. The next component was what I've called the market taker. Now, deploying models to production, thousands of them, obviously that becomes a scalability problem after time. What you want to be able to do is you want to test those models and say, it does not meet my standards of quality or the amount of predictions I'm getting. I want to remove it from production and make way for the next candidate. To accelerate that process, I created a backtester, or the CI part of CI/CD. The idea being that every data set I use to make my models is 120 days, the end of the data model is 120 days before today. The idea being that when the model's deployed to production, every night I can run the last 120 days of data through all the models that are in production. What that allows me to do is accelerate the failure rate to one night or 24 hours. I can run 4 months of data and I'll know within 24 hours what it would have done in 4 months. And I can dispose of the model far quicker than waiting the 4 months. So the problem with all this automation is it's literally coming and going like a transit station, and I don't know what's going on. So what I decided to do was build a Twitter account. And what Scarborough Fare does is as it deploys models to production and disposes of them, it tweets to a locked account, and also when it predicts. So I can see what's going on, and occasionally I'll scroll through that. So just to demonstrate what I've done so far. Model dispose. So that's the model being disposed in production. You can see there no predictions over the last 120 days, and so it has been disposed of. There's another example, and this is where it was less than 60% accurate over the last 120 days. And again, this would have been disposed of after it was tested. Conversely, a model deploy. Now, a model deploy is when Scarborough Fare has determined one of the models has been invented, developed, is worthy of deployment. You can see there the precision score is high. It's in fact perfect. It's set to a 1, and that's been deployed. So I quickly got some stats there that I want when it's tweeted out. And then the whole reason we're doing this is a prediction. So there's a sample prediction there. So you can see it's put in the model number. The confidence score in this particular case is set to 0.7. In recent months, I've set my confidence score to 0.8, and I won't accept anything less than that. So this is an older one. You can see there, though, it's given the announcement, the time of the announcement, and the website it relates to. The idea being that I can follow the trade and see if it actually plays out the way the computer's predicted. The next thing I built myself was a trading desk, a screen of sorts that shows me all the models, as you can see there. So the top list is some of the models in production that I've got deployed. The first column there is the true positive that we discussed before. So there where the computer has said there will be a successful trade, and in fact there was. False positive you can see are all zeros, but again, where the computer would have said yes trade and we would have lost money potentially. And then false negative and true negative. So true negative is when there was no trading opportunity, and a false negative is a missed opportunity. Now I don't particularly focus in that column, don't cry over spilt milk. We look at the opportunities where we would have put money on the table. But the false negative is good to see how many opportunities we miss out on. You can see the last two columns there, percentages of those two facts. Below that, in the table below, you can see I've selected the last model, and there's two predictions it's made. I've deliberately whited out the ASX code so no one gets any ideas. You can see from the details, the time, the title, the probability, or the confidence level of the model, the opening and closing price, and what it played out to be. So you can see in those cases it's 16 and 17% respectively. So in this case, it was a successful trade if we in fact had executed them. So I've been tracking that now for a couple of months, but before that all happened, there was a period of time where I built this and deployed this and not a single model was produced. Not one had met my criteria. And I think this period of time was about 2 months. And I was nervous. Was I wrong? Was I completely wrong? Were the maths wrong? Was my theory wrong? And so there was a long period of time where I really questioned whether I'd gone off on a weird tangent, and I was wrong. And then what I found was, after about 2 months, models started to be deployed. So through all these data sets, I tested all these different features, moving average, economic indicators, and models started to meet that criteria and be deployed. And I went through and looked at the top one, and the top one actually had a fantastic accuracy rate. It had 70% success, 70 right and 7 wrong. 7 wrong opportunities. Fantastic score, never seen it before. And I thought it was worth investigating. What had it picked? And what I discovered was it had picked a particular concept, is what we call a speeding ticket in the trading world. And a speeding ticket is when a company moves outside its normal price and volume parameters. So when that happens, the ASX notices that anomaly and will write a letter to the board of the company in case there's been a leak of information or something like that, and say, do you have an explanation for this movement, price movement or volume movement? And as you can see there, I put up a sample of a letter there that was given to a company a couple of months ago. And you can see from the title, the top line highlighted, price and volume query. It's a very common document, plenty come out days, weeks, all the time. And what the machine learning model had discovered was when this title of this document comes out, the price moves. Now, unfortunately, this document comes out after the price moves, so it's not a tradable opportunity. But what it demonstrated to me was that it learned something. It learned that when this document is published by a company, the price will move. So to me, while I haven't achieved my ultimate objective of being able to trade successfully on the ASX, it has demonstrated to me that I'm on the right path so far. So thanks very much for your time. And I've just got some resources there around some calculations, ML ops as well. Thanks for your time.